Hello guys, so in today's lecture we are going to talk about the dialyzer, the types of dialyzers, the history of dialyzer and their evolution throughout. So kindly be with this video and watch it till the end. You will get all your concepts cleared by the video. So let's begin. So firstly, what is a dialyzer? So the dialyzer is where the blood and dialysis solution circuit interact and where the movement of molecules between dialysis solution and blood across the semi-permeable membrane occurs. So basically, what is a dialyzer? So dialyzer is a place where the blood and the dialysis solution comes together, or we can say they interact with each other. And here the movement of molecules between the dialysis solution and the blood across a semi-permeable membrane occurs. So here what happens that basically the dialyzer shell is a box or a tube with 4 ports. So mainly अगर बात करें dialyzer की, तो basically dialyzer क्या है? Dialyzer is a shell or a box or a tube where we have 4 ports. Actually 4 ports because 2 ports communicate with the blood compartment and 2 with the dialysis solution. So mainly one is blood inlet from where the blood comes into the dialyzer. One is blood outlet from where the blood which is purified goes back to the patient. One is for the dialysis solution to come into the dialyzer and one is outlet for the dialysis solution. Here the membrane within the dialyzer separates the 2 compartments. So now here is a pictorial representation, brief history and advancement of dialyzer. Here we can see what are the hollow fibers which we are using today in our modern time. This is the dialyzer which we mainly use in our modern time. The second one is the parallel plate dialyzer, which before the hollow fiber dialyzer we were using. So this is the pictorial representation of the parallel plate dialyzer. Now history of artificial kidney or the dialyzer. So basically in 1945 Dr. William Coil developed the first workable artificial kidney, and the artificial kidney known as rotating drum. So the history of dialyzer begins with Dr. William Coil. As we all know that Dr. William Coil is known as the father of dialysis or hemodialysis. So he was responsible for the development of the first workable artificial kidney, or the kidney which we call as rotating drum. After that, in 1946, Niels Elwell, who just what he did is he developed the Coil dialyzer, and we can also say that he just advanced what Dr. William Coil had made. After 1948, Dr. Bodo von Gerlach began and brings the Coil dialyzer. So Dr. Bodo von Gerlach was responsible for the Coil dialyzer to come into existence. So we can say that he was the chief developer of the Coil dialyzer. In 1964, Frederick Kiel introduced the Kiel dialyzer. So basically these are the history in the ascending order. We can see 1940 from Dr. Coil to 1960 from Frederick Kiel. This is how the dialyzer development occurred. So next we are going to talk about the dialyzers. Firstly, we are going to talk about the rotating drum dialyzer, then coil dialyzer, then parallel plate, and then the modern day used dialyzer, which we also call as hollow fiber dialyzer. So firstly, Dr. Coil's rotating drum kidney. This is the pictorial representation or photograph from the Dr. William Coil's rotating drum dialyzer. So here is the brief history of this dialyzer. In 1945, Dr. William Coil developed the first workable artificial kidney. The artificial kidney known as rotating drum. So this was known as artificial kidney, which is called rotating drum dialyzer. It consisted of 30 to 40 meters of cellophane tubing in a stationary 100-liter tank. So here he just wrapped 30 to 40 meter cellophane, and it had a tank of around 100-liter capacity which contained water. The effective size of the membrane was around 2.4 square meters, and the clearance were measured in 140 to 170 ml min range. This device resembled a drum barrel made up of slates with open space between the slates. So it represented, or you can say it resembled drum barrel. So we can see here also that it somehow looked like a barrel with these are the slates in which there is some spacing. This is what this line states. Next, the cellophane sausage casing was wound around the drum. So here the cellophane was wound, that is wrapped around the drum. The lower portion of the drum, which was suspended lengthwise in the half barrel reservoir, was lowered in the dialysis bath. So here this is the dialysis bath. Here the dialyzer was, or we can say here the barrel was half dipped into this tank. Next, this procedure required around 2.5 liter of blood circulation outside the body. So this was interesting thing that this model of dialyzer required 2.5 liter of blood circulation outside the body. So we all know that an average human being has around 5.5 liter of blood inside the body, and during this procedure, while we were using the rotating drum dialyzer, around 2.5 liter blood was required outside of the body. Next, during the dialysis, the required priming with the blood transfusion. So for starting this dialysis treatment, what was required, that we have to prime it with the blood transfusion. So we have to always prime it with the blood. So this was a brief history about the rotating drum dialyzer, which were developed by Dr. William Coil in the year 1945. Next, we are going to the coil dialyzer. This is the cross-sectional area of the coil dialyzer. Here we can see this is some sort of a coil, and there is one chamber which is having the blood, and the other chamber is having the dialysate, and this is separated by a semi-permeable membrane. So there is the brief history of the coil dialyzer. In 1948, using concentrically wrapped membrane tubing to the blood volume membrane tubing. This was developed by Bodo von Garletz. So it was just a concentrically sphere which was wrapped by some membrane. What is the membrane? We are going to talk. It was also known as pressure cooker kidney concentrically wrapped membrane layer separated by fiberglass screening. So the outer surface was the fiberglass which was used, the material was fiberglass. This was a closed system, and the amount of ultrafiltration which was done using this dialyzer was actually some sort of measured, which was the drawback of Dr. William Cole's developed rotating drum dialyzer. Here we were unable to find the ultrafiltration values, but with the help of coil dialyzer we were able to find the values of ultrafiltration. So we can monitor the values of ultrafiltration in the coil dialyzer. Now next is the parallel plate dialyzer. So after coil dialyzer, parallel plate dialyzer came into existence. This is the image representing the parallel plate dialyzer. This was further modification of the coil dialyzer. Here we can see there are some plates. In one part of the plate the blood was moving, and other part the dialysate used to move, and the movement of the clearance of the solute was possible using the this model of it. So there is a the brief history of parallel plate dialyzer. Parallel plate dialyzer are composed of variable number of compartments in parallel, separated by rigid support structure enclosing flat sheets of membrane. So this was the design of the parallel plate dialyzer. Here the structure was separated through rigid network or rigid support structure enclosing flat sheets of membrane. Here the blood flow between the membrane layers while the dialysate flows counter current across the supporting plates. So this was the chief difference between the coil dialyzer and the parallel plate dialyzer. Here in one membrane layers the dialysate used to move. On the other hand, in the supporting structure the dialysate was able to move. Here, as the blood and dialysate flow resistance are low, the alteration is easily controlled and no or only minor backfiltration occur. So this was further advancement because we were able to calculate the ultrafiltration more easily, and the calculation was easily controlled, and there was very low backfiltration, which was not the case in the coil dialyzer. After the parallel plate dialyzer, we come across the hollow fiber dialyzer. So this is the design which we are using nowadays. It is practically the best design if we say with the surface area ratio with the dialysate. So here is a brief information about the hollow fiber dialyzer. Before going to the history or some facts about the hollow fiber dialyzer, I want to show you the structure. Here there is the blood inlet, here is the blood outlet, So there is the first entrance, this is the second entrance. So mainly there are 4 ports, 2 for the blood inlet and outlet, 2 ports are for the dialysate. This is solution, that is dialysate solution inlet, and this is dialysate solution outlet. This part is known as header, and these are the membranes which are embedded in this black sheet. This black sheet is mainly made up of polyurethane. This was the fiber jacket. These are the hollow fibers, and this is the jacket, which is the supporting structure mainly. So now this is the brief information about the hollow fiber dialyzer. So hollow fiber dialyzer consists of around 10,000 to 15,000 hollow fibers in a bundle, each end of which is embedded in a potting material. So as I told you, potting material mainly used for embedding these fibers is polyurethane. The fibers have an internal diameter of 200 to 300 micrometers. So the internal diameter of the polysulfone membranes or any fiber, mainly in today advanced world, the membrane which we use for making the fibers is polysulfone. However, polyurethane, polypan, other type of fibers are also made. So the fiber's internal diameter is around 200 to 300 micrometer, while the thickness is around 10 to 40 micrometer. The bundle is enclosed in a plastic jacket with ports for blood and dialysate line. Blood flows within the fiber, while the dialysate flow counter current on the outside of the fibers. So here the bundle is enclosed in a plastic jacket. So as we can say, these bundles are enclosed in a plastic jacket. These are mainly thermostat plastic. Now second thing is that blood flows within the fibers, while the dialysate flows outside these fibers. Because of its high effective surface area to blood volume ratio, this design is theoretically the best. So no more advancement can be done in the design of the dialyzer, because theoretically this design which we are using nowadays is best. Now the function and components of dialyzer. So this is the anatomy. You can take the screenshot of the, as I told you earlier, there's we have told the semi-permeable membrane fibers, the diameter, all are covered in the anatomy of hollow fiber dialyzer. Next is membrane and fiber characteristic affecting solute transport. This is another diagram showing the surface area of a single hollow fiber. So this is the single hollow fiber. Here the wall thickness, this is the internal diameter, this is the surface area. This is how the counter current flow movement occurs. The blood moves from up to downwards, while the dialysis moves from downside to the upside. And here the this we can say is the semi-permeable membrane, and here the movement of solute occurs from high gradient to low gradient. Next there is technical information about the dialyzer. So this is mainly called as header, and this is potting material. This is the housing or the jacket. These are the membranes. Again, this is the header. So mainly the header is made up of polypropylene. The housing is also made up of polypropylene. The potting compound or the potting material where the hollow fibers are embedded is of polyurethane. The membrane can be of cellulose triacetate, that is CTA, or of the eval, that is known as ethylene vinyl alcohol copolymer, or of PAN, that is known as polyacrylonitrile, polyester polymer alloy, that is called as polyether sulfone, that is called as PES, and other examples. Which is the most common which we use nowadays is that of polysulfone. Now in the next lecture we are going to talk about the dialyzer characteristics. So stay tuned with the next video. Until then, in this lecture we have covered the brief history about the dialyzer. The notes of this video will be given in the description box. Do share it with your friends. Like, share and subscribe. Thank you. God bless you all.